Hello. Thank you for taking the time to go through the assessment. Special thanks to Wendy Chandan from this website available, from which the idea was grabbed. Starting off, as you can see, before the Flask application loads, we load three things from the local directories. We load the Cocoa names and the config and the weights. So these three things are important for the pre-trained model of YOLO because it contains the labels and the pre-trained weights. So whenever we get a request, we load the model. So this is happening every time we're making a request. So it loads a pre-trained model from darknet and returns it to this main function. And we retrieve the image and we send it off to predict the labels. So as you can see that this Fox application is multi-threaded. So every time this thread is called, the model is loaded. So inside this prediction, so we get the yellow layers. So we are only focused on the last layer because the convolutional neural network has multiple layers inside, which is not important because this model is already trained. So we create a blob from OpenCV, and then we pass it through this layers. So this creates certain sort of detections that are found as part of an array, and we extract this array and we find the confidence and the class IDs. From there, we extract only the confidence which are 50% or more and return it as JSON object. The idea is that the server would be available as online as a RESTful API, and we would want to do that as part of Kubernetes cluster. But we'll get into that later. In order to build the cluster, we want to containerize the whole application and as Docker containers. And for that, we need to build a Docker image. So this Docker file would help to build the Docker image because it lists the requirements that are there. So this requirements.txt and lists the libraries that are required for the server to work. And we want to use the Python 3.7's Slim Buster library, which is the smaller version of the Python library, and install some C requirements that are required for OpenCV, and copy the requirements into a cache, and build the items from requirements.txt. Again, copy it to the cache folder so that the Docker image can be built. And we want to run the server.py, which is as the main function of this Docker image. Once that's ready, we want to build the Docker application using this following command. So it builds the Docker image, something called iWebLens is the name of the image, and the v1 is the tag, and we want to include everything in this file. So once that is done, we want to run the Docker container, and we will, because it's already running, this is the command that runs the container. So we want to run this container through port 8080 to 80. And the name of the container would be iWebLens, and the image would be iWebLens v1. So if we run a docker ps -a, that should show that the container is already running. So that's the available IP, and that's the name of the Docker container. So we want to deploy this as part of a kind cluster, so we can build this using client. So if we have a look at the kind configurations, so this is what it's doing. It's building two nodes, and one of them is the master, and the other one is the container. And the worker container has extra port mappings, which such that the container is at port 31000, and it can be accessed from port 80. Why 31000 is important can be seen later. So if we run kubectl get nodes, and we want to do the wide version. So that will show the nodes that are created. So the worker has internal IP, and the master has an internal IP as well. So we want to deploy pods on this. So if we do deployment, we can go through this deployment creation. So we want to mention the API version, and it's a deployment kind. It has certain information that labels it as a deployment. So the deployment is called iWebLens and has some labels. The specifications ensure that the replicas is 3. So that means that this deployment would create 3 pods, and each of them pods would have this template. So the label would be in key value format, which is the app, and the value is the iWebLens. Each of them would have container, and the image would be iWebLens v1, and they would be accessible through port 5000, and they have certain CPU limitations. And they can be accessed as part of the selector, which is right here. So if we have a matching selector, it should grab that specific pod. So if we see the services, defines the service that will run, and this is the load balancer, as it will target the specific pods as mentioned here by the selector, and it will ensure that the node port is open. This node port is the initial node port that we mentioned earlier, and this one is 31000. So this should be the main access point for our containers. So this service would ensure that the deployment is already always maintained and it's already there. And it will also target port 5000, which is the container. But the deployment is already running. It has three nodes, and the service is also up and running. So this is the service that is running. And if we run this again, we should be able to see the pods which are running. So these are the 3 pods that are running, and all of them have fine running status. So if we want to fire this, let's fire this as part of the request, and we will ensure that this has the external IP of the VM, which is right here. And this is from my computer, and we'll fire it with 4 threads. If we fire it, it should run fine. Yep, there we can see the outputs. And if we check the logs, we should be able to see them as well. So we want to see this log. Yep, so as you can see, all these are accepted requests, and we will try another one just to be safe. Yeah, let's try this one. Yep, this is also accepting requests. Describes the Nectar VM, and this is the external IP address. And what we've allowed is 2 security groups. This is for SSHing into the VM machine, and this is for the HTTP requests. So these 2 allow IPv4 requests to go in and out through port 80. And this is for IPv6, and this is for the port 443. As you can see here, the port is the nodes are accessible from the external internet.